Hello grade 9 students, welcome to our virtual class for the 4th quarter week 6. I'm Abigail Sarmiento, your science teacher. Our lesson for today is about heat, work, and energy. Overview. Have you tried to heat a pot of tap water in a hot burner of a stove? It is observed that the water temperature increases. In this situation, heat flows from hot burner to the cold water. When two objects at different temperatures are put in contact, heat spontaneously flows from an object of high temperature to the object of low temperature. The natural flow of heat is always in direction tending to equalize the temperature. If the two objects are kept in contact long enough for their temperatures to become equal, the two bodies are said to be in thermal equilibrium, and there is no further heat flow between them. Let us take, for example, when you have a fever, you will use fever thermometer in your armpit enabled to monitor your temperature. Heat is flowing from your armpit to the temperature. When the temperature reading stops increasing, the thermometer is then in equilibrium with your armpit, and they are at the same temperature. This module focuses on heat and work. It aims to explain how heat can be turned into work and how doing work releases heat. It discusses on the spontaneous processes where heat flows from an object of higher temperature to an object of lower temperature. Furthermore, how heat engines function, specifically car's engine, is given emphasis. It tackles also how heat pump operates. Efficiency of heat engines is discussed through some worded problems and its effects to the environment. Thermal pollution is explained as a result of rise in temperature of bodies of water that is detrimental to aquatic animals and is caused by the disposal of heated industrial wastewater. Being aware of the disadvantages of less efficient heat engines, we could design ways and means to lessen its effects. In your grade 7, it is learned that heat is related to temperature. Heat transfer may change one's temperature or one's phase. This change in temperature, either a decrease or an increase, means that there is an energy transfer in the form of heat. On the other hand, phase change means that there is a change in body's internal energy. We will be focusing only on the adiabatic or no heat enters or leaves the system. The concept of the conservation of energy states that energy cannot be created or destroyed. The first law of thermodynamics is actually based on this concept. It states that the change in internal energy of a system equals the difference between the heat taken in by the system and the work done by the system. Internal energy of a substance is the sum of molecular kinetic energy due to the random motion of the molecules. The for molecular potential energy due to forces that act between the atoms of a molecule and between the molecules, and other kinds of molecular energy. When heat flows in instances where the work done is negligible, the internal energy of the hot substance decreases and the internal energy of the cold substance increases. While heat may originate in the internal energy supply of a substance, it is not correct to say that a substance contains heat. The substance has internal energy, not heat. The word heat is used only when referring to the energy actually in transmit from hot to cold. The law is expressed as delta U equals Q minus W, where Q is the amount of heat flowing into a system during a given process, W the net work done by the system, delta U is the change in the system's internal energy. This is derived from the conservation of energy, given as how heat will use joules as our SI unit for energy. The first law tells us that a system's internal energy can be changed by transferring energy by either work, heat, or a combination of the two. And that is it for today's lesson. Please don't forget to subscribe to our YouTube channel, GAITF, or log into our account at lcms.gaitf.com so that you can answer the quizzes and activities given by the teacher. Thank you for listening.